Or, yep, what questions do we want to see? Do you go over on the shortcut? Show me on your hands. Not doing all of them. Okay, so I see a lot of 2s. Majority 1s and 4s. So we'll do those 3. Okay, so for number 1, Larry is taking a multiple choice test. The linear graph below shows his final score if he gets X questions wrong. What does the slope of the graph represent? So if I were to start at a point where it crosses the grid lines exactly like that one and go down to the next one, I can say my slope is negative 5 over 1. What did I just say? That we'd be going down 5, so our final score would be deducted 5 points, or minus 5 points for every question we got wrong. So the one that matches that is the change in his score by 5 points for every one problem he got wrong. D is similar, but it's saying the change is 1 point, which is not true, for every 5 problems we got wrong, which is also not true. So B is your answer there. Questions on that one? Yes. In general or this? The y over x. The rise over your run.
So it's negative 5.
Hold the top. It's negative 5 over 1, yes.
Oh, it is
You don't have that.
Okay. Yes. Oh, you know what? F. Yeah. Some of you have B, some of you have F. So F or B, whichever one. Yes.
the blue doesn't like cause every formula.
So this is counting by 5s, 150 to 145, and this is going over 1. So it is. It's going down 5 and to the right 1. There you go. Other questions on that one? Okay, so for this one, you needed to simplify, not solve. So at the end, you shouldn't get an x equals a number, but you should have an x and a constant kind of together in an expression. You needed to distribute first, either in your calculator or algebraically. So in your calculator, you would have pressed or gotten both fractions, alpha y equals 7/8 times, I forgot what that one was. 4/5. You also could have multiplied across, so 28 over 40, and then simplified that fraction, either or. But 7/10 was that simplified version. And then put x. Then you could multiply this in your calculator or do this by hand. If you're doing it by hand, something that might help is 8 goes into 16 twice. So I could really get rid of the 8, get rid of the 16, just put a 2 here, and multiply 7 and 2 to get 14. If you put that in your calculator, you would also get 14. So either way. And then multiply across. 3 times 1 is 3. 5 times 2 is 10. X. And then if I did the same thing here, I know 5 goes into negative 10 twice. So this would be really negative 2 or minus 6. So you can do that algebraically or in the calculator. And then we could combine our like terms. We have 2 sets of like terms. The x terms or the constants. There we go. So you would just do exactly as it says, add these two. Since the denominators are the same, you would just add 7 and 3 to get 10. would not change the denominator. And then combine these two, 14 minus 6 to get 8. And then this can be simplified to just 1. Or you could write it as just x plus 8. Either or answer is fine. Questions on that? So then moving on to number 4. For number 4, it tells us the slope in the equation y equals 1/2 x was changed to y equals negative 2x. We have to describe what changed and include both the slope and the y-intercept. So here I see the slope was changed and 2 things happened. It got steeper by 2, or is now 2 times as steep. And the slope reflected because of the negative. And nothing changed with the y-intercept. It stayed the same. So you should have 3 things written for that problem. Questions on that?
Wait, how did it work?
Because of the negative, it changed to a negative. That means it reflected. Other questions?
How do you grab 1/2?
So it's not asking us to actually graph it, but to visualize what would happen on a graph between these two, and looking at 1/2 and negative 2. The negative is taken care of because of the reflection. The 1/2 becoming 2 makes it, it's actually 4 times as steep, but whatever.
This one?
Yes.
I wrote that.
Yes.
Find the range.
You can ask someone else in the class, not at the second, but later, to find that one, since we already went over 3. But it's your y values. Okay, I don't remember if I asked this last class. I'm going to ask it either again or for the first time. We'll see. For the domain and range and for the problems in context delta math, did we have any questions that we wanted to see you go over together? I can pull that up on my end. We can do maybe a couple of those. Even if you don't remember what exactly it was, if you tell me which delta math it was, I can pull that up.
I think it was the most recent one.
Domain and range or problems in context. Okay. Stop. Because I'm pulling it off your account, so I need to know which one.
I don't know that I won't know about.
From the same.
No. I said different one. It was like September 6th.
So we're not going to go back that far, just these 2.
It's those 2 graph stories.
Okay, 1. Level 1 or level 2?
Level 2.
Okay. So if you've not finished this, make sure you, go back and do it because it was formative. But this is towards the end, the graphing stories. So you are given this story and you have to read through it and plot the points at the same time. I don't know if it's going to let me. We'll see. Okay, so on a spring day, Autumn noted the time of day and temperature in degrees Fahrenheit. Her findings are as follows. At 6 a.m., the temperature was 52 degrees. So at 6 a.m., this is starting at 50. There's a break in there. So this would be at 52. And then for the next 2 hours, the temperature rose 2 degrees per hour. So I know this is only going to go for the next 2 hours. It rose 2 degrees per hour. So that would be up 2 degrees for 1 hour and up 2 degrees for another hour. Oh, I didn't need to press all of those things. Okay, try again. You can either go to each point or you can just do the end. I found that they both work. And then for the next 6 hours, it rose 1 degree every 2 hours. So from 8, 9, 10, 11, 12, 1, 2, I'm going to be doing this. And it's going to go up 1 degree every 2 hours. So for this 2 hours, it went up 1. And then this 2 hours, it went up another 1. This 2 hours, it went up another 1. Did I do that right? 1 degree per hour, yeah, per 2 hours. For the next 6 hours. 1, 2, 3, 4, 5. I may have did that too much. 1, 2, 3, 4, 5, 6. Delete, just delete, just delete.
It's really hard to fix. Really using this up.
Yeah, some of that version. 2, 4, no, right there. Okay, and then it stayed steady until 6 p.m., so that means it's not going to change until 6. So at 6, I have another line, but straight. And then for the next 2 hours, the temperature dropped 1 degree per hour. So for the next 2 hours, it dropped 1 degree, and then another. And then the temperature dropped steadily until the temperature was at 56 degrees at midnight. So at midnight, it was at 56 degrees. I'm going to say I did not do that right, because it shouldn't be even like that. That part's right. Something in that I graphed wrong, and it's probably because I'm way too close to the board. The next 2 hours, 2 degrees per hour. 2, 2. Next 6 hours, 1 degree every 2 hours. 1 degree, 2 hours, 1 degree, 2 hours, 1 degree, 2 hours. Stayed steady until 6.
It was 6 hours, but you did 4 hours.
Is that what I did? Because that's 1, 2, 3, 4, 5. No, it is for 6. I start here and I go up 1, 2, that's 2 hours, 3, 4, 5, 6 hours. Then it stays steady. And then the temperature dropped 1 degree per hour. Definitely did something wrong there. I just cannot figure out what it is because I thought it was what you said, but I can't see it. But with these types of problems, take it slow. I will go back and find where I made this mistake and then re-show you, but we'll come back to that. I know I had, when I was practicing these before I assigned it, I did it a couple times because I was like, okay, I messed that up. Ariana, what was yours?
It was the last thing.
Oh yeah, so only if it was domain and range or the problems in complex. Okay, but you can get help with that after class or before school.
Let's call it
I tried to change those colors, but it didn't work. So look, for just the equations part, you were just setting up the equation, not solving anything. You had to write an equation that represented the total costs. You didn't know what that was, so that should have been some variable, something you don't know. You need one when he gets back. Okay. Because it said 0.18 per mile, you needed that to go with your x. Those should be multiplying next to each other. And then the plus 2660. Now, if you put 2660 first, and then plus 0.18x, that was fine, as long as you didn't move the x and put it with the 2760. Okay? And then part B was the same, similar, except you needed those numbers. You should have defined your variables. If you used different ones, that was fine, but you needed your variables to say what y or your variable and what x or your variable represents. Questions on those two? Practice. What? Okay. Part C, you are finding the total cost when given a certain amount of miles. So because miles is x, you're going to put that number in for both x's and figure out the total cost. One, that was your blue car rental. What was the total cost for that? $78. And then what was the total cost for the red car? $79.60 or $79.60. So then which company has the better deal? The blue, because it's cheaper by $1.60. Make sure you're putting it back on the hook. Then part E is similar to part C, where you are just changing the number of miles. So again, you're finding a total cost for both, but putting 400 in for x. So for the first one, the blue car rental, how much was that? What was that total cost? $95. $99. Sorry, I just didn't hear the second one. And what cents? Thank you. And then the second one? 96. Okay. $96.40. So it looks like before the blue one was cheaper, but after a certain amount of miles, the higher amount of miles you go, the red one becomes the cheaper one. Questions on any of that so far before we do problems F and problem G? Okay. Then for the last two, you had to find the miles instead of the total cost. You were given those. So for the blue, we would put this in for Y. And we would solve for x by getting rid of 2760 was. Someone subtract that. Tell me what you got. And then if we divided both sides by 0.18, x was what? If you didn't get that, go ahead and do that right now. $242. So do you have 0.43. Was that repeating? Or exactly?
I'm not sure.
I got one. I got
2 at the end.
yeah, but it was like
Okay, so just 22. Ask that again.
What's the gap between here for F?
I just ran out of space. So 242.2 repeating. And then miles. Because miles can be a decimal, we would leave it like that, but we wouldn't put all of those decimals. Questions on that one? Say it one more time. C. Okay, and then part G, you're doing the same thing, but now your total cost is $83.40. So subtract $40.40 on both sides. I'm gonna do this up here. It's my space. And divide both sides by 1.4. Say that again. 107? 307 point. Okay. 14. So previously we were doing our labels with dollars, but these aren't dollars, so you need to make sure you have labels in miles. Questions on any of those? We're going to do one more perimeter problem because we didn't get a chance to do another, and then we're going to move on. So in those same notes on the next page, last page, find the perimeter problems at the bottom. We're going to do number 11. So for this one, let's read through it. The length of a rectangle is 3 centimeters, less than twice its width. If the perimeter of the rectangle is 18 centimeters, find its dimensions. What's important there? The length of the rectangle. What about it? 3 centimeters, less than twice its width, that entire part. Okay. What else is important? Yes. And what are we looking for? We're finding both the length and the width. We don't need it to find the variables because it's going to be length and width unless you change the variables to something else. But that first part tells us something specific about the length. 3 centimeters less than twice its width. So I know it's going to be something about the width. The twice then means we're multiplying the 2 and the W together But the less than, not your inequality symbol, but subtraction, means that this number is going to go behind the 2w. So we're going to subtract it. So that would be one of our equations. Then we know the perimeter, which we talked about last class, is going to be some P equals 2L plus 2W to add up all the sides, both the lengths, both the widths. And we can replace some of those things because we know the perimeter is 18. And we know that the length has this equation, so we're going to put that in parentheses and put it in place of L.
What is that next to the 2? Next to the B?
The L. This is a cursive L. So then from this point we could solve it by doing what?
What is it called?
Multiplying, distributing the 2 to everything there. This one? Yes. Okay, from there. Yes, so 4 plus 2, you get 6w minus 6, and then what'd you say? We gotta do something with the 6.
Yeah.
Plus 6, add it, add it, add it. And then divide so that w is for what? Centimeters, yes. Okay. The dimensions, we gotta find both the width and the length. We found the width. We have this equation for length. How could we find it based on the width?
Very close.
Say that one more time.
Very close.
They told us the equation for it, but not what the length is.
Oh, wait.
You replace the W.
Yes. Yes. Put that 4 in for W. And find what the length is, which is what? 5. 5 what? And if you wanted to draw a rectangle and put your length of 5 and then 5 and your width of 4 and 4, you get 9 and 9, which is 18. Or you can put them back into the perimeter equation, you can get the same thing. Okay. We are going to switch gears now and go on to the other packet. So, I don't recall if I mentioned this before, I'm just restating. So, these are, 2 of these are the same learning targets as before, except now we have this new one, because we're talking about different types of solutions, so we're going to do that. So the steps to solve this when we have variables on both sides is going to be very similar to how we were solving last class, but there's extra steps. So if this helps you, use this mnemonic, call me after midnight, or distribute, combine like terms, move the variable or the constant. So before it was just the constant. By adding or subtracting. and you kind of do this step twice. You move one by adding or subtracting, then you go back and move the other by adding or subtracting, and then you get the variable by itself by multiplying or dividing. So similar to the last steps, but a little different. So we're going to work that out in this problem by first distributing on both sides at the same time. So that we get 8x plus 4 minus 2x, bring everything else down, equals 8 plus 4x plus 20. Say that again. Then we're going to combine like terms on the same side. So we see a bunch of x's and a bunch of constants, but we're not going to add and subtract all of them together. Whatever is on the same side, I can combine. So on this side, that would be what? 8x minus 2x. And then on the right, what could I combine over there? 8 and 20, yes. So only those on the same side can be combined. So 8 minus 2 will give us 6x. 8 plus 20 will give us 28. Bring everything else down. After you have combined like terms on the same side, then you can start to move things. Because once you get here, your goal is to get all the variables to one side and all the constants to the other. How you do that is up to you. You have choices once you get to this one. Pick one of these terms that you want to move first. Which one?
6x.
Okay, so if we move the 6x to the right by subtracting, we are going to have 4 equals 28 minus 2x. Because we moved the x's to the right, we now have to move the constants back to the left. So we're going to get rid of 28 by subtracting it over. So that we end up here with all the constants combined on one side, all the variables combined on the other, then we could divide. So the x equals what? It'd be positive because these are both negative. Questions on that process? On to the next page if there are no questions. So we're going to revisit just practicing some properties, noticing what's happening before we actually get into the solving piece. So same properties as before. Mine's a little blurry, so you may want to look at yours because it should be a little clearer. First one is still given, that's your regular equation, and we're looking at what changed, what happened between step 1 and step 2. 12, yes. So what did they do there? What changed? They subtracted 2k on both sides. So that would be your subtraction property of equality. And then from step 2 to step 3. Did they subtract? They added. So your addition property of equality. And then step 3 to step 4. Divide, yes. Both sides by 8. division property of equality. Okay. We're going to do another one together, then I'll have you guys do one really quickly. For number 5, the first one is given. What did they do next? We don't have parentheses, so there's nothing to multiply. Subtract what?
5 and 12.
The subtraction property of equality. And then yeah. The 7. And then what changed in 3 and 4? They switched it. That's called your symmetric property. That means you can take x equals -6 and switch it to -6 equals x. So you can switch that order at the end or at the very beginning. You could take this whole thing and put it on this side and this on this side, but not by adding or subtracting, because then you would be solving. Okay, I want you to try number 7 really quickly. Check your answers with mine. Some of us were still doing 6, but we should have been doing number 7. Do we have any questions on that?
This one. It was if I did the combined like terms after the subtraction, and I did the subtraction.
So in this one, because the order in which this is going, it distributed first, and then it combined like terms second. Then it subtracted. Go on to the next page. Find any questions you want to see, do, go over, have questions about. We didn't do that. So any that looks challenging, any you wouldn't be sure where to start. Which one? 4. Any others? We're not going to do 6 because it's going to be similar. I heard 9 and I heard one other number. 8. 8 is going to be very similar to 9. Okay. So starting with number 4, for any problem you see like this, if you see a fraction that equals another fraction, you're going to cross multiply, which means take this numerator and multiply it to this denominator, and this denominator and multiply it to this numerator. And then you have 2 choices. You could go ahead and multiply and write what that is, or you can rewrite it first and then multiply.
How would you rewrite it?
I'm going to do that. So if you rewrite it first, just make sure, it doesn't matter which side you put one pair on, just make sure they go together. And now it's like a normal problem. You got it out of the fraction, so you would distribute and start to solve. I'm going to show you how to start doing this a little bit faster. Which one do we want to move first? 45x, okay. So if I'm moving 45x by subtracting to the right, now, if this is too much, you can still do this in 2 steps, but you could do this all in 1 step. By at the same time, because I moved the variables to the right, I can move the constants to the left, and I can add 9. So that the 45x's cancel and the 9's cancel, leaving us with 54 equals negative 18x. So we basically did both steps just at the same time. And then divide. So the x is what?
Where did the 9 come from?
3 times negative 3. What is x? Close. Double pick up. Okay, so when you get a proportion or a fraction that equals another fraction, you can jump straight into this step where you multiply and then keep going, or you can rewrite it first and then distribute and keep going. That part is up to you. Questions on that? Yes. Yes. 7 is going to be very similar. So our very first step should be to do what? Okay. Rewrite by cross multiplying, yes. So 3 times b minus 3 equals 8 times b minus 4. Distribute. And then what do we want to move first? Anyone? 3b, sure. So by subtracting, at the same time I would add 32 to the other side. So that we get 23, I think that is, and 5b. Sometimes your answers will be decimals or fractions. If you get a decimal answer, and it's a nice decimals, which I think this one is, you could put that as 4.6. But if it's a repeating decimal or something with a long decimal, leave that as a fraction. Questions on that one?
What is that? I said that 2 to 3 to 5 equals what?
This part?
Yeah.
5b.
Oh, just 17.
Sorry. Other questions on that one?
What is this in negative 3b?
This?
No, the
This? Negative 3b plus 32. Okay. And then number 9, we would distribute both of these. So we have 8y plus 32 minus 2y plus 2. Be careful with your negatives. What would be our next step? So those like terms would be the ones with y's and the numbers. So that would be 6y plus 34 equals 70 minus 3y. What do we want to move? Pick something.
34.
Okay. If I get rid of 34 by subtracting, I'm going to get rid of 3y by adding. So that we get 9y equals 36, and divide both sides by 9. So that y equals what number? 4. So the checking your work for this works the same as before. You can take that number, put it in for all of your variables, and see if both sides are the same.
How would you start by combining the terms?
Where else would you start? We can't do anything with the stuff inside the parentheses, so we have to distribute to get it out of the parentheses. Okay. On to the next page. So there are two special cases that you need to know about when solving with variables on both sides. They are stated at the top. Infinitely many and no solutions. They will look like any other problem until you start to solve it. So let's do that. Start to solve number 1, distribute. Combine like terms. Right? And then at this step, what do you see? What do you notice? But also, you shouldn't be waiting for me to write. You should be trying and double checking at the same time. So before we solve, what do we notice about this? Anything stand out?
There's like 2 5x's.
There's 2 5x's on both sides. That should tell you this is going to be a special case. But also that these are different. So when we go to solve this, let's say I get rid of the 5x and get rid of 12. What happens?
0.
You get a 0 on that entire side and 17. Is that a true statement?
No.
No. So when you get something like this where your variables cancel and you get a not a true statement, that is no solution. Now you could accidentally get no solution by accidentally canceling out your variables, so be careful. If you were to check this algebraically, you could pick whatever number you want. No number will ever work for this. You could test it out a billion times with different numbers, but it would never work. Yes. Yes. Okay, questions on that before we do the other one? So again, distribute. And combine like terms. What do we notice about that one? They're both the exact same. That would tell you this is going to be a special case. So when I start to solve that and I get rid of 6e and I get rid of 10, what happens? We get 0 on both sides. And that is a true statement. So when your variables cancel and you get a true statement, this would be infinitely many solutions. Or INS. Opposite of no solution, you could pick all of the numbers in the world and put them in and they would all work. Okay, that those two notes are also written in the top. Questions on those? I want you to try 3 and 4. I'm going to give you like 5-ish minutes to do so. Talk to the people around you, but we're not moving. Okay, for number 3, what type of solution did we get for that one? Infinitely many solutions, or IMS. Did anyone need to see that one? Yes, okay. No solution for number 4, yes. So if we were distributing, we get 8r plus 12 equals 24 over 38, 36 over 12. So looking at this, these are exactly the same. So if you notice that, you can stop IMS, or you can keep going. And you'll get 0 on both sides. Okay. What type of solution was number 4? No solution. Did anyone need to see that one?
Yes.
Yes. Okay. So you could have started this a couple different ways. One, you could have combined your lit terms on the side, algebraically, or in your calculator. Or you could have started to move constants. That part didn't matter. If you combine lit terms algebraically, you would make this into a fraction. Get common denominators by multiplying both by 5. So that would be 10 over 5, and you could subtract. Or you can put that in your calculator. Then right here, I see that we have the same coefficients in the front of the variable, but different constants. So at that point, I could say it's no solution, or you could keep going. It doesn't matter which one you move, you're going to get no solution regardless. Because the numbers aren't going to be the same. Okay. We'll hold off on doing one of the last problems on the last page till next class, but I did want to show you how to check this in Desmos really quickly. So that while I just made up a problem that would give us something. Let's get rid of this too. If I just put in this equation, 5x plus 5x, 5x plus 5 equals 5x plus 5, you won't see anything. Nothing will appear. So you'd have to put in both sides separately. But because they're exactly the same, they're going to line up over top of each other. That would tell you that's IMS. But if we had 5x plus 5 and then a minus 5, again, you're not going to see anything. But if I were to put those in separately, I can see that right now it looks like they're on top of each other. But they're actually 2 different lines. So if you put them in and you get 2 different lines, that would tell you it's no solution. Okay? So use that to double check yourself. You do have a Delta Math on what we just did. That's also due on Friday. To include the other 2 that we talked about last class that are also due on Friday. So be working on Delta Math. If you have questions, raise your hand. I'll be around. If you finish the multi-set equations with variables on both sides and want to do retake work after you do that, then you can come see